I got a question over email, and it's a very important type of problem to know how to do. It's relevant both for the monopoly problems and the monopolistic competition problems. So anyway, this is the first problem, at least in the web-based version of the text in Chapter 10. So here we have information on price, quantity, and total cost for Andrea's day spa. And we're asked to calculate, well, we're asked to figure out what level of output maximizes profits. And so we're asked specifically to calculate total revenue, marginal revenue, average cost, and marginal cost. And then after we calculate that, we're going to be able to figure out what is the profit maximizing level of output. So I've done this in a spreadsheet, but before I go there, I wanted to just remind you of how we calculate total revenue, how we go from there to marginal revenue, get average cost and marginal cost. All right, so here's how we do that. So we have price and quantity. Remember that total revenue is equal to, I'm just going to put our definitions up to the right. Total revenue is equal to price times quantity. So I won't do this for every example, but if we have a price of 25 and a quantity of 0, total revenue is 0. If we have a price of 24 for each spa treatment and we sell 10, 24 times 10 is 240. If price is 23 and we sell 20, that is 460, and so on. And then marginal revenue, we're asked to calculate marginal revenue. And remember that marginal revenue, like any of these marginal concepts, is the change in total revenue. And with revenue and costs, we're always thinking about how revenue or cost change with output. Total revenue divided by output. So as total revenue jumps from 0 to 240, the change in total revenue is 240. Output, meanwhile, is jumping from 0 to 10. 240 divided by 10 is 24. And properly, marginal revenue is mapped between quantity 0 and quantity 10. In the spreadsheet that's to follow, I just map it on the 10, but that's because I don't have a middle space in my spreadsheet. All right, and then so on. For the next increment, as output goes from 10 to 20, total revenue goes from 240 to 460. That's a $220 jump. But we divide it through 220 divided by, again, a jump of 10. We have 22. And so on, you could calculate these columns. They're not too hard to do by hand, but they're a little easier to do with a spreadsheet. I want you to be able to do them by hand or by a spreadsheet. What else are we asked for? Average cost. Remember that average cost is equal to total cost. Total cost is just equal to total cost. But if I want to create a new column, average cost, or average total cost, remember that that's just equal to total cost divided by quantity. So we can't divide by 0, we get undefined. But if total cost is 275 and output's 10, our average total cost is 27.5. And likewise, if total cost is 435 and we're dividing through by our output level of 20, notice with average total cost, it's just one level of total cost divided by level of total cost divided by level of output. Say 43.5 is divided by 10, cut that in half, 21.75. That's done in my head late at night, so, well, what for me is late at night, so if I make an algebra error, pardon me. I'll check it by a spreadsheet in a moment. And then finally, we're asked to calculate marginal cost. And marginal cost, remember, is our change in total cost divided by change in quantity. And so, again, we would map that as we move from 0 to 10. Notice that total costs change from 130 to 275. That's a $145 dollar increase, but output is going up by 10. So 145 divided by 10 would be 14.5. And then as we move from output 10 to output 20, again, let's see, 275 to 435. That's a $160 dollar jump if I'm doing my math correctly. I think that is correct. And then output's jumping by 10, so 160 divided by 10, we get 16, and so on. We could calculate these on down. So I wanted to go through these definitions. Total revenue definition, we've done quite a bit. Remember, anytime you hear marginal revenue, it's always the change in total revenue divided by the change in output. And that marginal always should connote the change in one thing divided by the change in another thing. Average total cost, of course, that's old hat by now. Total cost divided by quantity. And then again, marginal cost. And you see the pattern, change in total cost divided by change in quantity. I popped this into a spreadsheet, and let me show you two ways to figure out the profit maximizing output. Okay, on this spreadsheet, I colored in orange the given information, and then we were asked to calculate total revenue, so I just did that for every level of output, just multiplying price times quantity, price times quantity, price times quantity. Doing it by hand gets sort of tedious. Doing it by a spreadsheet, it's just a quick formula. Marginal revenue, I took the change in total revenue and then divided by the change in quantity. Now the change in quantity is always 10. It's going up in increments in 10. So, that's pretty easy to divide by 10. But be careful. A lot of students will just take the change in total revenue and just report that as the marginal revenue, but that's not it. Remember, it's the change in total revenue divided by the change in quantity. Anyway, so I calculated via spreadsheet the total revenue, then the marginal revenue, and then we were given the information on total costs. From that information, I calculated average total cost, just taking total cost divided by quantity. And remember, this is divided by total level of quantity. So when we do that, we get this column of numbers. 1,225 divided by 60, 20.42. And then marginal cost, I looked at the change in total cost divided by the change in output, and I get this marginal cost. And here I'm plotting them against the ending quantity instead of in the middle, just because that's a little easier to do it that way. A little sloppy, but a little easier too. I went ahead and calculated this other column, profits. Remember that profits are equal to, we use the Greek letter pi. For profits, it's total revenue minus total costs. So I'm going to give you two ways to think about, you've seen this before, but two ways to think about maximizing profits. First way is this way that we tend to think about things in microeconomics. Oh, do we produce one more unit of output? The answer is yes, if the benefits of producing one more unit of output, that's marginal revenue, are greater than marginal cost. So do we go from 0 to 10? Yes, because we're getting $24 for the new unit, for each of the new units of output, and it's only costing us $14.50 for each of the new units of output. Would I trade $14.50 for $24? You bet, all day long. The next increment up to going from 10 to 20, we're getting $22 a unit. It's costing us $16 for those last units. That's a good deal. Do I increase to 30? $21.50. Marginal revenue is greater than marginal cost, $17.50. Yeah, I'll make that deal. And even for going from 30 to 40, marginal revenue is $20.50, so that last spa treatment offered gets us $20.50, and it only costs us $19. Well, it's not a big margin, but remember these are economic costs, and economic revenues. So if the benefits of increasing output are greater than the costs of increasing output by 1 unit, then it's a good deal. So yes, we'll go from 30 to 40. Now, do we go from 40 to 50? Notice that marginal revenue, that is $20 per spa treatment, but as we move from 40 to 50, the marginal cost is $20.50. Would we spend $20.50 to get $20? No way. We're losing money on that deal. We're not going to do it. So we stop at 40. 40 is our profit maximizing quantity. And then in a perfectly equivalent way, and when you have numbers like this, it's maybe easier, probably easier at least to calculate profits. Here we can just scan this column and just look, what's the level of output where profits are maximized? Oh yeah, there it is. And indeed I highlighted it in teal. And profits there are 80, higher than at any other level. And one way to check your work is to see if this marginal revenue greater than marginal cost way of calculating the profit maximizing level of output is the same as just scanning the column of profit values. If they're different, then you've made an error somewhere. Anyway, that's how you do these problems. And it's perfectly analogous to the way we did these monopoly problems graphically. Notice that these relationships hold. I'm not trying to scale, but we've got this downward sloping demand curve. It's not exactly linear, but it's downward sloping. We've got this accompanying marginal revenue function. We've got a upward sloping marginal cost function. And as long as marginal revenue is greater than marginal cost, we keep increasing output. We produce the quantity where marginal revenue and marginal cost are just equal. And the price, notice that marginal revenue was $20.50 at this profit maximizing level of output. The price was $22.50. So it's a pretty flat demand curve. That's not much difference, but it is nevertheless a difference. So P sub M. And these are the reason why this demand curve is so flat. This is a monopolistically competitive problem. There's a lot of these spas around. So either way, whether you do it marginal revenue, comparing with marginal cost, keep increasing output as long as marginal revenue is greater than marginal cost, stop when that ceases to be true, or whether you just look for profit maximization, where profit's at its highest. Either way is equivalent. That's how you do these kind of problems. Very important category of problem.